I am -5 years old. JavaScript lets me do this. What? That's not possible. How can anybody be -5? Isn't that concerning? It feels like I shouldn't be able to do this. But again, that's perfectly fine JavaScript. Now, what if I told you we could throw an error if you do stuff like that? Like this. That'd be cool, right? Can't be -5. And what if I told you we could throw an error if you set your name to something crazy? Like, I don't know, an empty array. Like this. Oh, that's your name? You're an empty array? I don't think so. You could do both of these without TypeScript or any library, just pure vanilla JavaScript. This is possible using something called JavaScript Proxies. It's a type of object, and I'm going to show you how to use them. This is a series called 25 Things JavaScript Developers Should Know But Probably Don't. This is episode 22, JavaScript Proxies and the Incomparable Reflect API. Let's go! So, what is a proxy? A proxy is a JavaScript object that lets you create custom behavior for basic operations. You can intercept reads and writes, existence checks, function calls, all sorts of basic foundational operations. It's like setting a security camera around your object. You can see and react to everything that's happening to your object. I'm gonna show you 6 or 7, that wasn't even planned, benefits and ways that you can use, that was amazing, JavaScript proxies, and we're gonna touch on the Reflect API also a little bit. So let's get practical. To the browser. Or to Run.js, which is this thing I use that everybody asks me about. It's still my favorite tool to learn JavaScript. If you wanna get Run.js, you can go to runjs.app/colorcode, and that's like an affiliate thing with Run.js folks. So I have an object here, const me, name, Sina, age 1, such a baby. We can wrap it inside a const proxy, my proxy, equals new proxy. I'm gonna pass in me, Johnny T. And then what we're gonna do is we're gonna write what's called a trap. This is called a get trap. Target and prop, I think. And we're gonna return, what should we return? Target and prop. So we haven't changed anything, return. So what I'm gonna do is I'm gonna have just a basic console log that says accessing prop. Oh wait, I forgot to say this. Number 1, basic intercept. It's the magic of cinema. We can edit things after the fact. Prop, this should work. So now every time I access proxy, let's log my proxy, console.log, my proxy dot age. Look at this, we get a custom log when we're trying to access proxy. Actually, I don't have to use age, I can use whatever I want. Yeah, proxy.name, perfect. So we didn't change the object, we just started watching it. A very practical, real world use case for this exact pattern is when debugging where your state is getting called from. For example, you have a React app and one of the properties of your state is getting read over and over again, and it might be causing re-renders for you. If you write React code, you know that that's actually a big deal. And you don't know where it's getting called from. Wrapping it inside a proxy lets you track it without modifying the entire app or having to write a bunch of logs in all sorts of places where you're calling your state from. We can actually log the stack trace here. So let me change this to say, I'm gonna add new error. So let's say I wanna throw an error for some reason, .split, /n, stack.split. And so what we get here is the really ugly string of the entire stack trace. Doesn't tell me much because the stack trace right now in Run.js doesn't actually have much in it. So I'm gonna create a couple functions, fun1. Fun1 is gonna call fun2. Of course, we don't have fun2, and then fun2, let's be consistent with our indentation bits. Fun2 is gonna do the actual my proxy.age. And then we're gonna call fun1, right? So you can kind of tell my stack trace is following, fun2, and then fun2 is getting called from fun1. I'm not gonna make this look any nicer, but you can imagine how you could split this into individual levels and find yourself much needed information if you wanna figure out where stuff is getting called from. A quick note about, I'm gonna get rid of all this and also the new error. And I'll do my proxy .h. So a quick note about my proxy and this whole business of creating a new object. You might think, hey, this is annoying. Really, I have to create a whole other object just to watch my original object. This is annoying, but also I won't be able to go and change every instance where I'm calling my object and change it to my proxy. And you're right. So a different pattern that people use, it's very common, is they actually assign the original object to a proxy. And now any reference to the original me is going to go through this proxy logic. This is actually the most common way proxies are used in real systems like Vue. I believe Immer.js and MobX also use this. You're not creating a new proxy object. You're just creating a new handle to the same object. There is a downside to this, which is any reference to the original me that was created before this proxy is going to hold on to the original reference and is not going to go through your proxy logic. So that's a kind of a gotcha that I want to make sure I mention. Honestly, some of those nuances are beyond the scope of this video. For the purposes of simplicity and for the rest of this video, I'm just going to use this pattern, which means we're not going to create new objects. We're just going to assign the original to a new proxy. Okay. Number 2, protecting individual properties. So let's say you never want certain properties to be read. For example, let's say I have, let's say I have a password and the password is that. I'm gonna get rid of this and I'm gonna say password. So right now, password is coming back, but I could say if, get rid of console, if prop equals password, I'm gonna throw new error, and I'm gonna say access denied, yo. Password's not gonna come back, but name is gonna come back. This is access control, baby. We are building our own runtime level permission system. Isn't that crazy? No TypeScript, no decorators, all of this is just raw JavaScript. So what are some real world scenarios? You may not get the password to come back from the server, but you might have, salary information, social security, your admin level, your tier, your billing tier, stuff like that. And you might be wondering, why would I want to deny access to certain properties? Should they not even come back from the server? And my answer is maybe. You probably don't want to have full access control on the client side. A lot of this stuff should be done by the backend also. And that is a legitimate point. But you can imagine use cases where having this kind of control on the client side can be really useful. One that I can imagine, UI libraries and SDKs, for example, want to be doing is you can't really assume that all of the consumers of your SDK should have access to this, should be able to expose all sorts of properties, so you can kind of protect yourself this way. So this was a little bit about the get function. How about writes, right? This was a read. So number 3 is sanitizing writes. What if I want to lock down parts of my object so you can read it, but you can't write to it? And I do want to be clear, this stuff should be reinforced on the backend too, right? An example of this would be, for example, location, right? My location is coming back from the server, this says NY. I want to go ahead and say my location equals something else. Something Italy or California. I can change this get to be a set. And set actually takes a value. I can say if this is location, access denied, or let's be a little bit more gentle about it. You can't overwrite location. I can't do that, but I can do location. I can do name, Sina, and now let's do target prop equals value, I think. Value. And then target prop, I'll just return true, I guess. And let's change the name to Oli. So my object's now changed with Oli, but if I try to override location, I get an error. You can be a little more sophisticated about it and not just throw an error like that, but I think you get the point. Again, to be clear, client-side access control is not real security. It must be reinforced on the back end too. So I just want to make sure you don't get the wrong idea here. Now, going back to the idea that I opened the video with age, right? What if, something simple, -5. I was saying you shouldn't be able to set the age to something negative, right? Instead of just simply throwing an error like that, we can say if it's age and value is less than 0, I want to say age should be positive, right? So -5 gets an error, but 10 does not. This is defensive programming in action, which, by the way, I have a full video on defensive programming. Check it out, yo. And this is happening right at the property level. You're protecting your object from bad data. Number 4, auto-fallbacks is what I call them. So if I can protect rights, we can also set up default values. So let me just copy this so I don't have to type it and torture you by watching me type. I can say, what's the example I have here? So I can say city. Oh yeah. So if I can say me.name is CNAP, but me.city, let's say it does not exist on my object. Normally what I would get is city. Let's do console.log. I get undefined, right? But if I want to be a little bit nicer about it, I can say, hey, that thing is not found. This means you don't crash anymore from undefined properties. It's just a safer fallback, kind of like optional chaining, but this is now customizable. Number 5 is conditional read-only. We kind of touched on this already, but you can make just a part of the object be read-only, kind of like object.freeze, but this has more control. More specifically, you want to say which properties I want to protect. Again, I'm going to show you this real quick because we kind of touched on it already. I can say user, and then user has a password. If I want to change the password, 123. You can't modify this, yo. The point I'm trying to make is that this is kind of like object.freeze, but at a specific property level. This way you're freezing only some properties and not all of them. Number 6 is virtual and dynamic properties. So this one's kind of insane. Let's say I have a product object. The price is $100 or 100 whatever, and I want to give it a discount, and I want to be able to see product dot, final price, for example, final price. So it doesn't exist, right? I can create a dynamic property like a function that is not a function. Wait, what? Let's add the proxy to it and I can explain what I mean. So we can get a final price. And the final price, I can have whatever logic I want. In this case, take the discount off of the total price and then return the final price to be 80. And now you have a property that kind of acts like a function, but it's not a function. It's a simple property. Holy shit, what does this mean? I'm glad you asked, Oli. This means a few things. You have properties that don't actually exist. It's a virtual property. At least that's what it feels like to the consumer of your object. 2 is you have a dynamic property. This is something that now changes with the rest of the object, right? So if I change the discount to be 40%, now final price is also changed. That is very, very cool. And this is how part of Vue.js actually work. I mentioned this a little bit earlier. So you might say, okay, well, that's cool, but this is exactly like a function, right? So why do I need this? So what? Well, I'll tell you so what. But first, I'm gonna take a sip of water because I'm thirsty. So why is this better than function or method, right? Number 1, the consumer experience is a little different. Looking up a property is different than invoking a function. Call me OCD, but I think this is nicer than this. I know it's just a couple of parentheses, but to me, this feels a lot more like a final API product than having to invoke a function. I mean, come on, it's better. Fewer things to type, less things to remember. I like it. But the second thing that happens is you can write logic once and use it for multiple properties. For example, you can say if the property starts with an is, you can treat it as a Boolean. This is something that sort of as a convention we've come to accept in our industry. There are some emotions in there. I'm sure some of you don't feel like this is the right pattern, but when a property starts with is or has, usually unofficially it means it's a Boolean. So if I have a get, if I'm gonna replace this with a slightly different one, I can say Let me make this a little bit smaller. You can have a function that's called compute boolean, and every time, every property that comes in that starts with is, we're going to treat it the same way. Or whatever logic is in compute boolean, you don't have to write it over and over again. This basically now applies to as many properties as you might have in your object. Now, this is a little dangerous, right? I understand if you have the urge to write a comment and say, Sina, I don't think so. So I agree, you gotta know what you're doing with stuff like this. I wanna make sure everybody understands you have to use virtual properties with discipline. If you're thinking, listen, it feels weird to have properties that don't actually exist. What happens to documentation? I can't look up these properties now. You're absolutely right. You're thinking the right way. I feel you. Object.keys is not going to return final price, or JSON stringify for that matter. That means debugging becomes a little harder in this case. Consumers can't just guess the name of your properties, right? So you have to make sure you document this properly for anyone who might be using this code as a consumer. There's also a performance overhead to using traps like this. So deeply nested objects are going to get slow. Now we're talking, many layers deep and many hundreds or thousands of objects. So if you're using this within a small scope, you're fine, but you should know there is a little bit of an overhead there. But with all of those caveats, it is kind of a JavaScript superpower that you can create properties that are dynamic and virtual that I thought you should know about, and you can achieve that using proxies. Before we go to number 7, I want to talk about proxies and the Reflect API. So I mentioned this in the beginning of the video. There is something called the Reflect API. You'll see it often used with proxies. I think it's like the official way or the supposed way to perform operations on objects. When you're using a proxy, I'm gonna do another copy pasta here. Instead of using a target prop, like this, you're supposed to use the reflect.get and the reflect.set. I should probably dedicate a whole video to reflect, but for now, all you need to know is that this is the preferred way to perform operations on objects when you're using proxies. You should use reflect, get, and set. I tried to do a little research on why that is. I didn't really get a practical, satisfying explanation other than, it's cleaner, it's safer. There are some safeguards around reflect that you don't have with target prop. And I also read there's a couple of use cases where if you're using inheritance or symbols, reflect's going to protect you from some errors where target prop does not. So yeah, just think of reflect as a mirror universe of your object. Use it within your traps. And lastly, number 7 is validating function calls. You can use a proxy to intercept function calls too. So let's say I have a greet function here that just spells out my name. Sina. Hello, Sina. Great. So I can create a safe version of this. Const safe greet equals new proxy. I'm going to send the greet in there and let's dance. So apply function called target this keyword arg and my arguments. I can say if type of args 0 is not string, throw new error. Expected a string, damn it. Otherwise, we're going to return reflex.apply target this arg. Clean up a bit. Okay, safe greet. Safe greet. Suna. Can't type my own name. Misspelled. See, this is one of the fun things about writing custom functions and custom logic. You gotta know what you're doing. So I had a typo there, so Sina's fine, but if I do, I don't know, my name is an empty array, right? Like the beginning. Expected the string, throws an error. Or I can do 1, 2, 3. It's not a string. You're wrapping a function with runtime guardrails. It's like combining validation and execution all at once in one place. Where would I actually use this? I think this is used pretty heavily when building schema validators. I don't know if you and I are gonna be building schema validators. You can mock some APIs in your tests. This is useful. If you don't want to change the original function, you can use the proxy that way. Like I said, the Vue uses this quite heavily when they have this reactivity systems. And I think the data binding in Angular also uses a similar technique. Vue 3, from what I understand, literally rebuilt their entire system using proxies. So every time you update the state, you're using the proxy under the hood. So a couple of warnings here. Proxies are really powerful, but with great power comes a couple of things. Potential performance hit. I talked about this a little bit already. Using traps like this is slower than just using plain objects. We're talking, again, thousands or hundreds of thousands of objects that are deeply nested. You're not gonna feel it unless you are using it at that scale, but just be aware, it is a difference. Number two, you can definitely shoot yourself in the foot if your traps are wrong. Like I had this before, and this is actually a fun little accident that just happened. If I have an error in here, if I have an error in my logic, not this error, but a mistake in my logic, having this is really powerful, but you can see this is actually a bug. So make sure you write tests for all of your logic. You want to make sure that what you're doing with your custom logic is actually correct. And number three, tooling and debugging gets a little bit harder, especially with those dynamic properties. They're not going to show up in your object.keys or JSON stringify. Some linters and IDEs are not going to be able to see all this stuff, and they might get confused. So yes, proxies are awesome, but wield them with purpose. Okay, so I think that's it for today. This has been episode 22 of 25 things JavaScript developers should know but probably don't. Next episode is on, I don't know, maybe Reflect API. We touched on it today. Maybe symbols. I don't know, you tell me. Tell me in the comments below what you want to see next. But for now, play with some proxies and see how you can make your code safer and more robust. Okay, see you in the next one, and Happy New Year, everybody.